So looking at question 11, we have a fruit packing company produced peaches last summer whose weights were normally distributed with a mean of 15 ounces and a standard deviation of zero point 0.8 ounces. Among a sample of 1,000 peaches, about how many could you expect to have weights of more than 12.2 ounces? So looks like I need a couple things here. So let me pause the video here and so the way we can do this is if we can convert this to z-scores, then we can probably make this problem work. Let's see what happens here. It could be empirical or it could be z-scores. So we have a mean of 15 ounces. So let me put the actual values over here on this side. So the mean is 15 ounces. That's in the middle. And then we had a standard deviation of zero point 0.8. So if I add zero point 0.8 to 15, that's going to give me 15.8. And then plus another zero point 0.8 would be, what is that? What's 15.8 plus 0.8? 15.8 plus zero point 0.8. So 16.6. And then plus another zero point 0.8 would be what? 17.4. Then if I lose zero point 0.8, so 15 minus zero point 0.8 is going to give me 14.2. And then minus zero point 0.8 again, it's going to give me 13.4. And minus zero point 0.8 again, it's going to give me 12.6. So our question is saying the nut peach is expected to weigh more than 12.2 ounces. Well, it looks like based on what I'm seeing, all of the peaches should weigh more than 12.2 ounces, if unless I'm missing something here. So the mean was 15.8. So yeah, you're like talking all of them. So we could still go ahead and do z-scores and see if that gives us what percent that gives us, but it should give us like 100%. So let's see here, because you're out way out there on this thing. So that's an interesting question. So now if we convert these to z-scores, what I can do is go z equals, so we have 12.2 is the x value. If we subtract the 15, which is the mean, and divide that by the standard deviation of zero point 0.8, that'll give us a z-score. So if we do that, 12.2 minus this 15, divide that by zero point 0.8, we're getting like a negative 3.5. So if we go to negative 3.5, if we go to find that on our table, so on our table, negative 3.5, notice that that's like our table goes to negative 3.49, which is 0.002. So again, notice how I'm not even getting that z-score to show up on my table very well. So, but basically, you know, 2% or well, that's like if you move the decimal, that's still saying like 0% is going to be left of negative 3.49. So that means 100%'s got to be to the right of it. So that's a weird question to have. So our answer is going to have to be then all of the peaches. So 1,000 peaches would have to be more than 12.2 ounces based on that graphic.